Hello. I recently got access to flow simulation. So, if you saw my post recently, I came up with an idea for an automated ventilation system for caravans. The idea here is basically what you see here is that the fans are split up into groups mainly for switching purposes, and that makes it easier to group them. But you can see the idea there is that they've all got a little sensor inside each compartment, like the living area, the battery box, and gas compartment. Basically, are the three areas of use for an example. You could have up to like 6 different compartments in the board. So that you can see there in like the main compartment, the little yellow areas are where the sensors are, and the arrows are just to show like the intended flow of air for those areas. It's not really meant to be a positive pressure system. It's not meant to be something that stays on during travel. The idea behind it was something that if you're in storage, because I see camper trailers and that often have a lot of problems with mildew and mould and such building up, and it's often because they're so well sealed against water and everything that it causes that build up from just moisture in the air and so on. Of course, a lot of gas systems are self-ventilated. There's also some rules about battery boxes that have come in that I'm not totally familiar with. As far as I understand with caravans, it's just to be treated now as like with motorhomes and that, where it's like, a separate compartment basically to the living area. If that's so, then this really isn't. It's kind of a redundant system, and or the system could still be self-ventilating. It just wouldn't be attached to the main living compartment at all, like what's shown in this drawing. The battery box and the gas compartment are drawing air current through from the main compartment and therefore from the Group 1 fan. So the idea there with the battery box area here is that if the battery box heated up too much, if that compartment began to get too hot or humid, it could drain the heat out a bit, or attempt to alleviate the heat by flowing air through from the front of the vehicle through the living compartment and then through the battery compartment. That's how the switching would work. Like it would trigger that sensor, which would activate the Group 1 fan, then Group 2 fan. Same goes here. Where you'd have the little temp sensor, would also have a O2 sensor, so it can sense the emissions in the area, and then depending on the feedback of those sensors, if there's a certain amount of humidity, temperature, whatever, then it will switch the fans for those areas. Again, switching Group 1, then switching Group 3, just for the ventilation sake. That's just an idea. So I've used just like that little LCD screen with like the controls on it sort of thing, because mainly I was thinking that I wanted to save cost on the larger touchscreen display and stuff. But honestly, if you were trying to make it look pretty professional, you'd probably just build a little unit to house the Arduino board and the the screen itself. So I've just used an Arduino Uno in the example there. But you could use an Arduino Mega or something. I don't know what the requirement is. That's where I need help. There's an example of the circuit idea. So I know how to run all the wiring for it and how to power it and switch it all and stuff like that. But I really need help with the Arduino sketch, the coding for it. So if anybody out there knows how to code or do this sort of stuff, please let me know. I could really use the assistance with it. Especially if too, like, where do I need to put the transistors and the breakdown, do I need something between the battery and the Arduino board? I'm pretty sure I do. I can merge it into one connection line there, but I'm pretty sure I need like a dropper or something in place. So an electrician or a coder or something like that, if someone sees this and knows how to, I would, I'd really appreciate the help with it. So yeah, please help. But here's just an example, of how flow simulation and stuff can be used to help with caravan design and such. So I make the bodies and the curvature of the bodies and stuff, and just with Flow Express, this is just the Express version shown here, mainly because it's really cheap and nasty. as far as it loads really quick on my computer sort of thing and runs better. So if I'm just checking, for the flow of how I want the curvature of the front of a van to work sort of thing, then this one's really good for that. But the bigger baubles that it shows here, I call them baubles, the bubbles that it shows there sort of thing, they're a bit of a pain in the ass. They're not 100% accurate and they're harder to work with and stuff. You can see here I'm trying to flip through like the number of lines that it's giving to try to accurately see the flow a bit better. And this includes our cutouts for the ventilation system. Eventually I can test the ventilation system just using the intake and outtake. Mainly here I just wanted to see how heavily, like using it as a positive pressure system, how much wind and everything like that, how much is it actually intaking, because that's how much I'd have to filter. So knowing the intake and outtake areas is easier to filter. So if you're thinking bull dust can get through anything, yes it can, but if you know where it's coming in, then you can prevent it a lot easier sort of thing. So we can filter against it heavily. Even if you've got to have like a little unit, like a 100 mil unit on the outside of the fans that houses the heavier filter, then so be it. See the tubes there, it really helps me see the exit, like where the wind is coming in and where the wind is exiting. But I don't like the tubes for the effect. I think they're big and bulky and they look ugly, look like snakes. So I try to just use this one for my flow stuff, but it is heaps better for seeing pathing. And so here, like we're taking a look at like the outlet sort of thing, which shows you like that suction on the rear end of the vehicle, which is good because if you look closely there, we can actually see that there's some intake that's resulting as some of that suction at the rear end there. So we're actually getting intake into our fans there. Would that be enough to stop the flow that's coming out from inside the van? I don't know. So so to have a closer look at this sort of stuff, we really need to get into flow simulation, the actual flow simulator, and have a look in there. My computer runs for crap with this thing. It's got way too many particle effects. Like it actually looks all right in my screen, but recording it through is difficult. Saving it and then exporting the videos and stuff is a painfully long process. So what I'll show you here, a flow simulation in just a sec, will be yeah, that's how it records on my computer. It looks a bit better on my screen, but I'll get a dedicated computer for running this sort of software and stuff like that. But it's also where this sort of software fails against Autodesk. So dear salt, keep that in mind. Autodesk have systems where you can send files away to be uploaded on a cloud, like rendered through and dealt with in a cloud-based loading system, like on servers and stuff, and then spit the information back to you. Much faster, better way to process information. This is awesome because you don't need any access to anything. It's the full program. It's all operating there and everything. But speed matters too for us poor people with busted ass computers. Okay, so there in this picture here, you can actually see the little row of bubbles at the back moving directly into the intake. So that's a problem if that was bull dust, because if you've seen vans moving before, they build up all that bull dust at the rear end of the vans as they tow along. So here we see the flow simulation, and see. So I don't know if it's moving fast enough in the video for you to sort of be able to see the motion there, but it's very clear, and it's much better when I'm watching it and governing for design and stuff like that. But see, you can see the pressure build up on the inside there. which is a lot better now because it's also showing us, we can see the velocities of the air that's being pushed out of those areas. So, you know, like we're seeing the effect of its positive pressurization there. And we can actually measure that system and show the numbers, like how much pressurization it's get based off our wind flow. We've used like 17 meters a second sort of thing in the setup for this, which wasn't a huge amount. You know, we could go a lot higher because like for tow velocities and stuff like that, you know, if you're towing against a wind or anything like that, we can look at higher systems and stuff. But that's also another reason why, you know, you don't want fans going. That could easily overload the system and everything. So you want those blocked off or something. I don't think it would be a positive pressurization system for during tow, but for storage, it would be incredible. It would be a great system. Like you can see there in this, the amount of air that just these fans create inside your van, the amount of flow that it creates is integral in many ways, just as far as it really it diminishes all that mildew, the buildup of molds and everything like that. It heavily helps all of your fabrics and stuff like that during the van. It gives longer life to things, timbers and such that do build up organic materials like molds and everything like this. They absorb moistures in the air. If they're trapped in a space like that, moisture finds way to get into places. So you know, just that ventilation can make all the difference. And if you've got a camper and you have to take it out, you know, days before you've got to take it out, so you've got to open it all up and keep it ventilated and all this sort of stuff, an automated system to run all that for you would be pretty good, especially depending on your charge setup, like your solar setup for it. It could be a very, very minimal intake. But this is the same view just with arrows. Because I thought maybe some people might have problems with the video outlet, like seeing the direction that the bubbles were going, whereas this is the arrows, so you can see it a lot more. And that's the so this is based off pressure at the moment, like the Mesa scale there's based off pressure, because we're checking like the pressurization there on the inside and stuff like that. But it also, you know, for velocity sakes and stuff like that, we can see some good information out of these reports as well too. Like there at the front of the van, you can see like the amount of wind that's hitting the van. You can see the dampening of the wind by the shape of the front end of the van. So you can see it hits the front end there with a bit of force, but then it's instantly being diminished by the top curve of the van. So it hits that curve, rushes up the curve, and then, you know, you can see that pressure drops out of it then at the top end there. You'd see something different with velocity. With velocity, I believe that you'd see that it would actually hit the front end there and speed up along the top of the van and slow down heavily around the rear end. But you can see the curve at the back end there doesn't diminish the force as much as you might think it does and everything. Rear end does create a lot of suction, but that big wall is always a problem. I'll try to figure that out in another study. So please try to support Hunter Caravan Design by following us on Facebook or Patreon. Website is still incoming. I'm going to try to work on that crap. All designs are available on Patreon or by request. Just hit me up on Facebook or something. If you wanted a model or anything like that to muck around with yourself, always there. Happy to give it out. Thanks very much for watching. Links below. Have fun. Bye.